So with the photoelectric effect, you're gonna have a metal like this, as janky as it may be. So this metal is basically our element. It's an element. So you're gonna have an element. So element. So every element has its own absorption and absorption spectrum. So that means when you shine a light onto your element, so this is gonna be a light. So when you shine the light onto that particular element, depending on the intensity, on the frequency, and on the wavelength of that particular light, and electrons are gonna jump from that metal. The electrons in the element are gonna gain energy, and then they're gonna jump from that element, and they're gonna jump out. Because if you guys remember, every element, let's say an atom, because an element is the same thing as an atom anyway. So here you're gonna have your nucleus. Then the nucleus is surrounded by electrons. So if that light is shined on the atom, the electron is gonna gain energy. And from it gaining energy, it's gonna jump into the next orbital. But sometimes that energy is a bit too much. So instead of jumping to the next orbital, it's gonna jump out of the atom. And that's how you have an ion of an element. So I don't know, like, do you guys understand that?
Yes, sir.
So basically, when the electron jumps out, it gained energy from the light. So you need to know the energy. You need to know how to find the energy. And since it's jumping, we know that it's gonna move. So it's not potential energy, that's kinetic energy. And we know the equation for kinetic energy is 1/2 the mass and squared velocity. So since it's the photoelectric effect, this mass, it's always gonna be the mass of an electron, which they give you guys, I think, yeah, it's here. So since you know that this light is gonna give the electrons energy, you need to know the minimum energy required for that electron to jump out of the element. That minimum energy, it's usually your work function. So this is the symbol for the minimum energy required for an electron to start jumping. So the total energy of the electron, the total energy in this particular system, E, is gonna be your minimum required energy. added to the energy that the electron has afterwards, which is your kinetic energy. Sorry. Does that make sense?
Yes, sir.
Okay, so this equation, you're mostly going to be using it. And so do you guys know Planck's constant?
I don't.
Planck's constant H. Do you I think from like grade 11 work, you guys will learn that energy is equal to Planck's constant multiplied by the frequency. This is like an equation from grade 11. Because if you look at it, Planck's constant is in joules seconds. So let me just write it down here. Planck's constant is in joules second. But your frequency is in per seconds. So 1 hertz is equal to 1 per second. Do you see that?
Yes, sir.
So you are aware that 1 hertz is equal to 1 per second, right?
Yes, sir.
Okay, so if you look at it like this, this is to the exponent 1, this is to the exponent -1. When you're gonna add this and this, they're gonna cancel each other out because it's gonna be second to the exponent 0. What you're gonna be left with is joules. And the SI unit for energy is joules. So that's why your energy is the Planck's constant multiplied by the frequency. So do you get it?
Yes, sir. I got it.
Okay. So mostly in this section, you're gonna have to know how to calculate the velocity. You're gonna have to know how to calculate the kinetic energy. And you need to know what your work function is, which is the minimum energy required. Because most of the time they're gonna give you guys a graph. And on that graph, they want you to find your work function. They want you to find the kinetic energy. And you need to know how to calculate your total energy. So your work function, since you know that energy is equal to Planck's constant multiplied by the frequency, your work function is basically Planck's constant multiplied by the minimum frequency, F0. So this is a crucial, you need to know this equation, you need to know this equation for kinetic energy, you need to know the equation for the total energy of the electron, and you need to know your equation for your work function. This is equation number 1. This is equation number 2. equation number 4. And this is your fifth equation. So for you guys, when it comes to the photoelectric effect, you need to know only 5 equations. But they're mostly going to be provided to you in the formula sheet. And you need to know only 2 constants. I think that's the mass of the electron and Planck's constant. That's everything we're going to use for this section. And I think I gave it to you guys here. Yeah, this part. These are all the equations you guys are gonna use, including these 2. So I think now we can get started. We can I think now we can go through the question. Is that fine, or is there a question with any of the equations?
Can go through a question, sir.
Okay, so I think question 11 is based on it. Question 10 is generators and motors. So yeah, it's question 11. So the threshold frequencies of calcium and potassium metals are given in the table below. So your threshold frequency, that's your FO. So that's same time you hear threshold frequency, you just know that it's the minimum frequency required for an electron to escape or jump out the atom. So they say define work function in words. Work function, I already defined it to you as the minimum energy required for an electron to escape. I usually say jump out, but it's actually escaping the atom. So now we're gonna go to 11.2, where you say which one of the 2 metals in the table has a higher work function, and give your answer by referring to the information. So since we know that our work function is equal to Planck's constant and our threshold frequency, I mean, it's the product of Planck's constant and threshold frequency. Planck's constant, it's a constant, so it doesn't change. We're just gonna look at the frequencies and check which one has the higher value. So potassium has a higher threshold frequency. So in 11.2, you just state that potassium has a higher threshold frequency, and the reason is because potassium has a higher work function. The reason is because it has a higher threshold frequency. I think that's simple enough. Then we're gonna go to this section where they say the simplified diagrams below show circuits A and B containing photocells. The photocell in circuit A contains a calcium metal, while the photocell in in B contains a potassium metal plate. So ultraviolet light is shown on the potassium metal plate and the calcium metal plate. And they gave us the wavelength. They gave us the wavelength of the UV light. And the metal plates are connected to an ammeter, which registers a current. So they say, by means of calculation, determine whether the ammeter in circuit B will also register a current. So we have our work function here. So guys, when they say that the ammeter registers a current, that means electrons from the calcium metal plate are jumping or are escaping from the metal. So when they say we must calculate whether this is also reading a current, that just means we have to calculate whether the energy of the UV light is greater than the work function or is greater than the threshold frequency. That's what they want to know, because if it's greater than the threshold frequency, that means electrons are also jumping from the potassium metal plate. Do you understand that?
Yes, sir.
Okay. So I'm just gonna go to like our formula sheet real quick. So we know that E, the energy, is equal to HF. But now, since they gave us UV light, we have to find the frequency of the UV light. So in order to do that, we're gonna go to our formula sheet. So guys, here's the equation that we can use, because we know we have to determine the energy and find out whether the energy is greater than the work function, or we find our frequency and find out if that frequency is greater than the threshold frequency. So these are like the two ways that we can get to our answer. So we can use this equation because we know the speed of light, that's 3 times 10 to the exponent, I think 9. What's the speed of light? Yeah, 3 times 10 to the exponent 8. And we find our energy. Because they gave us the wavelength, we can find our energy. And on the side, we can also calculate our work function now. And through these two calculations, we can find out either this energy is greater or less than our work function. Greater, less than, or equal to our work function. then through that information we can determine whether it's reading a current or not. Do you understand that? Or maybe was I going a bit too fast?
I got it, sir, but what's the wavelength?
The wavelength, they gave it to us here.
Okay.
Yeah, so first let's calculate our wave function. So that's gonna be Planck's constant and the threshold frequency. So our work function, let me get my calculator real quick. Planck's constant, that's 6 point. Where can I find the formula sheet real quick? It's like just 10 minutes left. 6.633 3 times 10 to the exponent negative 34. So negative 34. And this is all multiplied by our threshold frequency for potassium, which is 5.5. Times 10 to the exponent 14. .5 times 10 to exponent 4. What answer did you get?
I got 3.68 times 10 to the power of negative 19 joules.
Okay. So our work function, you said 3.6?
8.
Okay. Uh, 19 joules.
Yes, sir.
So now we can find our E, the energy of the light of the UV light. So that's gonna be E is equal to HC over lambda. So that's gonna be H, which is our 6.63, times 10 to the exponent negative 34. So this is multiplied by the speed of light, which is 3 times 10 to the exponent 8. All of that is divided by our wavelength, which is 5.5 times 10 to the exponent negative 7. So you can just quickly put that in your calculator. 83.4 times 6, 3 times 10 to the exponent 8. All that divided by 5.5 times 10 to the exponent -7. What did you get?
I got 3.62 times 10 to the power of -19.
Okay. Can you recalculate this? Because I think I got a different answer for that.
Okay, so
because I know usually my calculator has some problems from time to time. So since here we got the same answer, can you check yours for the work function?
I get 3.65 times 10 to the power of -19. Looks like.
Yeah, I also got that.
Okay.
You can see that the UV light doesn't provide enough energy for an electron to jump out of the potassium metal, because 3.62 is less than 3.65. So according to this information, the energy provided by the light is less than our work function. So that means that this ammeter in circuit B will not register any current. I think just let that marinate. And is there a question for this?
So if you had to put that in words, would you say like the energy provided by the light is
It's
less than
not
the
enough.
minimum?
It's not
Okay,
enough for an electron to jump to escape, so no current is registered.
Okay, thank you, sir.
Or you can say the energy is less than the energy required for an electron to jump, so no current is required. But they just said by means of calculation. So I think if you just say this at the end and say that no current is registered, it would still be a mark. So this is saying like we have 2 minutes left. Let me just exit, then restart. But at this pace, I'm probably gonna have to do that like 3 times. Do you guys have a problem with using Google Meets? Because with Zoom, it takes a while for me to like cut it, then come back, then cut it, then come back.
I'm fine either way, sir.
You're fine either way. So I'll try to use Google Meet in our next session, and see if that's better. So let me just stop